Hi everyone, today we'll be looking at the January 2020 P2 paper. In question 1, we've got a table of values for x and for y being log of 2x base 2, and using the trapezium rule, we need to obtain an estimate for the integral from 2 to 14 over log 2x base 2, giving our answer to 1 decimal place. So the trapezium rule is given in the formula sheet, so the integral of 2 to 14 of log 2x base 2 will be approximated by a half times the height of the trapezia, which is the difference between two consecutive values of x, which is 3, and then we put the first and the last y value once. So it's gonna be 2 plus 4.81 plus all the intermediate y values twice, so 3.32 plus 4 plus 4.46, and we plug everything on the calculator. This is giving an answer of 45.555, which is 45.6 to 1 decimal place. In part B, using our answer to part A, we need to estimate these two integrals. So somehow we need to build connections with the answer in part A. So we start from the integral from 2 to 14 of log of 4x squared base 2 over 5. Now we notice that 4x squared is just 2x all squared, and by the power law of logarithms the 2 can come down, so it's the integral from 2 to 14 of 2 log 2x base 2 over 5 dx. So it's 2/5 of the integral log of 2x base 5 dx, and this is 2/5 of 45.555, which is 18.2. Now for II, we've got log of 2 over x from 2 to 14. So I could start by writing out that the integral from 2 to 14 of log of 2 over x base 2 dx can be written as the integral from 2 to 14 of log 2 base 2 minus log x base 2 dx, which can be written as the integral from 2 to 14, 1, because log 2 base 2 is 1, minus log x base 2, and then I will add 0 in an intelligent way here. I'll write minus log 2 base 2 plus log 2 base 2 with respect to x. So this here is essentially 0, which will allow me to write this as the integral from 2 to 14 of 1 minus log of 2x base 2, because minus log x base 2 minus log 2 base 2 can be written as minus log 2x base 2 plus 1 the log 2 base 2 dx, which is the integral from 2 to 14 of 2 minus log of 2x base 2 with respect to x, which is the integral from 2 to 14 of 2 with respect to x, minus the integral from 2 to 14 of log 2x base 2 with respect to x. So we simply get 2x from 2 to 14 minus the 45.555 that we obtained in part A, which is 2 times 14 minus 2 times 2 minus 45 times 555, which is negative 21.6. In question 2, one of the terms in the binomial expansion of 3 plus ax to the power of 6 is 540x to the power of 4. We need to find possible values of a. So I'm not gonna consider the full expansion. I'm just gonna say that I'm interested in the coefficient of x to the power of 4. So this is 6 choose 4, 3 to the power of 2, ax to the power of 4 plus dot dot dot. So a kind reminder here that the sum of the two powers should be giving me the original power. So 6 choose 4 according to the calculator is 15. 3 squared is 9. A to the power of 4x to the power of 4, which further gives me 135 a to the power of 4x to the power of 4 plus dot dot dot, and therefore equating the x to the power of 4 terms, I get 135 a to the power of 4 is 540, which means that a to the power of 4 is 4, so a squared is 2, and therefore a is plus minus root 2. I got two values for a, which agrees with the fact that the question was referring to possible values of a. And in part B, hence find the term independent of x in this expansion here. So we've got 1 over 81 plus 1 over x to the power of 6 times 3 plus ax to the power of 6. Now we need to start off by considering the fact that the only way to get a constant term, a term independent of x, is to have a constant times a constant, or something over x to the power of 6 times a term in x to the power of 6. So in other words, I will keep the 1 over 81 plus 1 over x to the power of 6, and from the expansion of 3 plus ax and all to the power of 6, I just want to keep the first term, which is 3 to the power of 6, plus the last term, which is ax to the power of 6. Now this is 1 over 81 plus 1 over x to the power of 6, and in the other bracket I've got 729 plus dot 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 plus a to the power of 6 x to the power of 6. So it's easy to see that we've got two pairs that will give me a constant, a number that does not depend on x. So it's 1 over 81 times 729 plus 1 over x to the power of 6 times a to the power of 6 x to the power of 6 plus dot dot dot. So the x to the power of 6 simplifies out, and we get 9 plus, well, a is plus minus root 2, and this is raised to the power of 6. So this gives me 9 plus 8, which is 17. Obviously, the fact that I've got an even power here makes the plus minus insignificant for the final answer. In question 3, we're being given f of x here, and we need to use the factor theorem to show that 2x plus 3 is a factor of f of x. Now we know that if 2x plus 3 is a factor of f of x, then by considering 2x plus 3 is 0, which gives me that x is minus 3 over 2, then f of minus 3 over 2 is expected to be giving me an answer of 0. Let me substitute this into the given expression. It is 6 times minus 3 over 2 cubed plus 17 times minus 3 over 2 squared plus 4 times minus 3 over 2 minus 12. This is giving me an answer of 0, and we need a conclusion. Therefore, 2x plus 3 is a factor of f of x as required. We always need the conclusion here to claim the final mark. Now in part B, it says hence using algebra, write f of x as a product of 3 linear factors. So I've got one linear factor, so I'm gonna perform long division here. 6x cubed plus 17x squared plus 4x minus 12 divided by 2x plus 3. So I will multiply 2x by 3x squared to match the highest order term on the left. It's giving me 6x cubed plus 9x squared. I deduct. I get 8x squared plus 4x minus 12. So I've got plus 4x here. 8x squared plus 12x. I deduct once more. I get minus 8x minus 12. So I need a minus 4 here to give me minus 8x minus 12. A result of 0 as expected, a remainder of 0, which means at the moment I can write f of x as 2x plus 3 brackets 3x squared plus 4x minus 4. Obviously, I need to go a step further and express this as 3 linear factors. This obviously factorizes further into 2x plus 3, and we've got 3x minus 2, x plus 2. In part C, we need to solve for theta between pi over 2 and pi. This equation shown here, giving answers to 3SF. Well, what's the connection with the previous part? Well, obviously, x has been replaced with tan theta. So I will start by solving f of x is 0, and then seeing what kind of values I get for tan theta and therefore for theta. So I will start by saying that f of x is 0, which means that 2x plus 3 is 0, or 3x minus 2 is 0, or x plus 2 is 0. So we've got x is minus 3 over 2, or x is 2 over 3, or x is negative 2, which means that tan theta is minus 3 over 2, or tan theta is 2 over 3, or tan theta is negative 2. We are in radian mode. I'm gonna generate the PV for each of these simple trigonometric equations in tan. First one is giving me that PV is minus 0.98279. The second one is giving me that the PV is 0.58800, and the last one that the PV is minus 1.10715. Now, we can generate solutions by considering that I could add or subtract multiples of pi, the period of tan. So theta is minus 0.98279 plus pi n, or theta is 0.58800 plus 2 plus pi n, and theta is minus 1.10715 plus pi n. And the only solutions that are between pi over 2 and pi are 2.03 and 2.16. In question 4, we are being given a graph, y is 2x squared plus 7. We've got the shaded region R here, and we need to find the exact area of R. I will start by determining the x value of the point at which the y value is 17. So in order to do that, I will be solving 2x squared plus 7 is equal to 17. 2x squared is 10, so x squared is 5, and therefore x is root 5 because x is greater than or equal to 0, and therefore the x value here is root 5. Now, in order to calculate the area of R, the idea is to find the area of the rectangle and then deduct the area under the curve, and what I'm left with is obviously the region R. So R will be given by 17 times root 5, which is the base times the height of this rectangle. Take away the integral from 0 to root 5 of 2x squared plus 7 with respect to x, which is 17 root 5 minus 2x cubed over 3 plus 7x from 0 to root 5. I will be substituting the upper limit. That will give me 2 root 5 to the power of 3 over 3 plus 7 root 5. And the lower limit is obviously 0. So we want the exact answer. We have to be careful here. We get 17 root 5 minus 2 over 3, and root 5 cubed is root 5 times root 5 times root 5. So it's 5 root 5 plus 7 root 5, which is giving me 17 root 5 minus 10 root 5 over 3 minus 7 root 5. They are all root 5 terms, so this is giving me 20 root 5 over 3 units squared. In question 5, we've got a colony of bees under study. We know that at the start of the study we have 30,000 bees, and 3 years after the start of the study we have 34,000. The suggested model is predicting an increase of p% on an annual basis so that we form a geometric sequence. And we need to find the value of p. Now, being told that 3 years after the start of the study means at the end of year 3. So I'm trying to approach these questions by forming a table that matches the wording of the question. So I will say at the end of year 1, 2, 3, just to see exactly on what's happening. At the end of year 1, we had 30,000 times 1 plus p over 100, because 1 plus p over 100 is the factor that corresponds to an increase by p%. So at the end of year 2, we have 30,000 times 1 plus p over 100 to the power of 2. And so at the end of year 3, it was 30,000 times 1 plus p over 100 to the power of 3. And this is what we're being told is equal to 34,000. So 30,000 times 1 plus p over 100 to the power of 3 is equal to 34,000. I will divide by 30,000 to get 1 plus p over 100 to the power of 3 is 34,000 over 30,000, which means 1 plus p over 100 is the third root of 34,000 over 30,000, and therefore p over 100 is the third root of 34,000 over 30,000, take away 1. And if I multiply this by 100, I get p to be 100 times the third root of 34,000 over 30,000, take away 1, which turns out to be 4.260360, which is 4.2622 decimal places. Now, according to the model, at the end of capital N years, the number of bees exceeds 75,000, and we need to find the smallest integer value for n. So I will start by saying that after capital N years, what I'll be having here is 30,000 times 1 plus p over 100 to the power of n. And I need to solve this being greater than 75,000. That's the equation we need to solve. So let's start off by writing the equation. We will be using some logarithms here. I will be using full accuracy for the value of p. So I will start by dividing by 30,000. 1 plus p over 100 to the power of n is greater than 75,000 over 30,000. So I'm gonna use the value for P stored on my calculator. I'm gonna take logs. So log of 1 plus P over 100 to the power of n greater than log of 75,000 over 30,000. I'm obviously taking logs base 10 here. You could take any base actually. The n can come down, so n log of 1 plus P over 100 is greater than log of 75,000 over 30,000. And therefore n must be greater than the log of 75,000 over 30,000 over the log of 1 plus P over 100. Put everything on the calculator as it stands, and we get that n is greater than 21.96, and therefore we conclude that the smallest integer value is 22. In question 6, the circle C has equation x squared plus y squared plus 6x minus 4y minus 14 is 0. We need to find the coordinates of C and the exact radius of C. So I will start by completing the square. I'm gonna first write the equation with the x terms together, x squared plus 6x, and then the y terms together, y squared minus 4y minus 14 is 0. So I will complete the square, x plus 3 all squared minus 3 squared plus y minus 2 all squared minus 2 squared minus 14 is 0. And this leads to x plus 3 all squared plus y minus 2 all squared is equal to 27. We know that the circle with equation x minus alpha squared plus y minus beta squared is equal to r squared has center alpha beta and radius r, and therefore we can safely conclude that for part I the center has to be negative 3,2, and for part II the radius has to be root 27. Now, the line with equation y is equal to k, where k is a constant, is a tangent to C. It says find the possible values of k. I think it makes perfect sense here to draw a quick sketch of a circle. So here we go, we've got the circle, it's centered at negative 3, 2. We've got a horizontal line, the line y equals to k, which is a tangent to the circle, so it could be this line here, or it could be this line over here. We already know that the radius is root 27, so we know that this distance here is root 27, so it's easily seen that to reach k, we either need to go root 27 above the y coordinate of the center of the circle or root 27 below it. So we simply have to say that k is 2 plus minus root 27. Part C, the line with equation y is p, where p is a negative constant, is a chord. It's a chord of length 4 units, and we need to find the value of p. So again, looking at this sketch here, we've got the line y equals to p. There it is. We are being told that this has a length of 4. And we need to find the value of p. What I will actually do here is I will zoom in a bit just to see clearly what's happening. I will draw this line here, it's a radius, so this is root 27. Now, the radius here is bisecting the chord, and therefore this distance here is just 2, and I will call this here h. Obviously, I'll be using the Pythagoras theorem here to find h, and based on the value of h, I'll be able to conclude on the value of p. So Let's start with Pythagoras theorem. I'm gonna say that root 27 all squared is 2 squared plus h squared. So 27 is 4 plus h squared. 23 is h squared. So h is root of 23. And therefore, P is the y coordinate of the center of the circle, which was 2 minus root 23, because we knew that P was negative. So we had to go down in order to make sure that P turned out to be negative. In question 7, we need to show that this equation may be written in a form that involves only signs. So I will start by writing out the original equation. And then the obvious thing to do is write tan as sine over cos. And then I will cross multiply to get 8 sine theta is 3 cos squared theta. I will express cos squared theta as 1 minus sine squared theta. And upon expanding, I see that if I collect everything on the left-hand side, I'm getting exactly the printed answer. So 3 sine squared theta plus 8 sine theta minus 3 is equal to 0, as required. Now in part B, it says, hence solve for x between 0 and 90, the equation shown here. Now the hence means there is a clear link between A and B, and therefore I can see that theta became 2x. So it immediately means that I can write this equation as 3 sine squared 2x plus 8 sine 2x minus 3. In other words, the result we have already established to be true for theta is also true for 2x. This is a quadratic in sign. Sometimes it's useful to introduce a w. In our case, it will be sine 2x in order to see that this leads to 3w squared plus 8w minus 3 is 0. So a familiar quadratic setting here, which factorizes into 3w minus 1 w plus 3 is equal to 0, and therefore either 3w minus 1 is 0 or w plus 3 is 0. So we get w to be a third, which means that sine 2x is a third, or w is negative 3, which means sine 2x is negative 3. Now for sine 2x being negative 3, obviously we've got no solutions, we reject, it's not valid, because sine of any angle will attain values between minus 1 and 1. Minus 3 is not attainable, so no solutions on that branch. But for sine of 2x being a third, we can generate the PV. The principal value is shift sine of a third, which is 19.47122, which means that 2x is 19.47122 plus 360n, or 2x is 180 minus 19.47122 plus 360n. I will divide throughout by 2, leading to x being 9.7356 plus 180n, or x is 80.2644 plus 180n, and therefore we're looking for solutions between 0 and 90 to 2 decimal places. It's only 9.74 and 80.26 degrees. Question 8, an arithmetic series has first term a and common difference d. We need to prove the formula for the sum of the first n terms of this series. So I will call this Sn, which is the first term plus the second plus the third plus dot 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 up to n including the nth term. Now we know that the first term is a, the second term is a plus d, The third term is a plus 2d, and the last term, the nth term, is a plus n minus 1d. Now, I will rewrite this in reverse. I will start from the last term going on to the first term. So it's going to be a plus n minus 1d. The next one will be a plus n minus 2d, and so on up to n, including the first term, which was a. Now, the reason for doing this is that if I add this vertically into a pairwise fashion, I get Sn plus Sn is just 2Sn. But then if I pair them up here like this, I see that all these pairs are always giving me the same sum. It's 2a plus n minus 1d n times. Why? Because we've got n pairs added up here. Each pair is giving me a total of 2a plus n minus 1, and I've got n such pairs. So it's going to be n brackets 2a plus n minus 1d. So Sn is n over 2, 2a plus n minus 1d, close brackets, as required. Now in II, we've got a sequence u1, u2, u3 given by this, and we need to find the value of u5 and then the sum of the first 59 terms. So let's start with the easy part. Now u5, we just substitute n is 5, so we get 5 times 5 plus 3 times minus 1 to the power of 5, which is 25 minus 3, which is 22. For part B, to find the sum from n equals 1 up to 59 of un is just u1 plus u2 plus dot 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 up to u59. Now, if I put n to be 1, I will be getting 5 times 1 plus 3 times minus 1 to the power of 1. So this is u1. For u2, it's going to be 5 times 2 plus 3 times minus 1 squared. And this will continue, this pattern will continue up to the last term. So the next term will be 5 times 3 plus 3 times minus 1 cubed plus dot dot dot. So I could actually start by considering these terms first of all, because it's gonna be 5 plus 10 plus 15 plus dot 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 plus 59 times 5. So we've got the multiples of the first 59 multiples of 5 added up, and then the other terms here will be alternating between -3 and 3. So it's going to be -3 plus 3 plus -3 and so on, with the last term being a -3. So they will all cancel out, the -3 with the +3, the -3 with the next +3, and I will be left with the -3 here. Now, this part here is just an arithmetic sum of 59 terms, with first term being 5 and common difference being 5. So according to the formula we have already found, it's gonna be n over 2, 2a plus n minus 1d. And the other bracket here is just contributing this -3 here. So it's gonna be plus a -3. And this is giving me a result overall of 8,847. In question 9, we need to sketch the curve with the equation y is 3 times 4 to the x, showing the coordinates of any point of intersection with the coordinate axis. This is an exponential graph. It has a horizontal asymptote, the x-axis. We know that when x is 0, we get that y is 3 times 4 to the 0, which is 3. The greater the value of x, the greater the value of y, so it's going to be something like this, cutting the y-axis at 3. Now in part B, we've got the curve with equation y is 6 to the 1 minus x intersecting the curve with equation 3 times 4 to the x, and we need to show that the x coordinate of the point of intersection is given by this here. So we will start by equating the two. So 6 to the 1 minus x is equal to 3 times 4 to the x. It makes sense to take logs of both sides. So log of 6 to the 1 minus x base 10 is log of 3 times 4 to the x base 10. So 1 minus x log 6 base 10 is equal to log of 3 base 10 plus log of 4 to the x base 10. Now I will expand. I'm gonna write log of 6 base 10 minus x log 6 base 10 on the left, and I've got log of 3 base 10 plus x log 4 base 10 on the right. I will collect the x terms on one side and the rest on the other. So I've got log of 6 base 10 minus log of 3 base 10 is equal to x log 4 base 10 plus x log 6 base 10. Now log of 6 minus log of 3 is log of 6 over 3 base 10. And on the right hand side I will factor out the x, and I'm left with the log of 4 base 10 plus log of 6 base 10. So we have log of 2 base 10 is x times log of 24, because the sum of the two logarithms is the logarithm of the product, base 10. So log 2 base 10 over log 24 base 10 is equal to x as required. Question 10, we've got a curve with this equation. The point P with x coordinate a half lies on C. We are being told that P is a stationary point. This means that dy dx is 0. We need to show that k is negative 3 over 2. I will start by writing y as 4x cubed minus 9x plus kx to the minus 1. So dy dx is simply 12x squared minus 9 minus kx to the minus 2. Now, P being a stationary point means that when I substitute x is a half into dy dx, I expect an answer of 0. So 12 times a half squared minus 9 minus k times a half to the minus 2 is the expression for dy dx at x is a half. This is giving me 3 minus 9 minus 4k, and all of this is 0. So minus 6 is 4k. So minus 6 over 4 is k, which is of course simplifying to minus 3 over 2 as required. B, determine the nature of the stationary point at P, justifying your answer. One way to do this is to consider the second derivative approach. So the fact that we satisfy dy dx is 0 means that it could be a stationary point that is a maximum, a minimum, or even a point of inflection. So I will consider the second derivative in order to establish the nature of the stationary point. The 2y by the x squared will be 24x plus 2k x to the minus 3. I will substitute the value of x being a half together with the value of k that we have established to be minus 3 over 2. I'll plug everything on the calculator here and I get an answer of negative 12. This is less than 0, therefore it's a maximum. Remember that you need to show explicitly the comparison with 0 and write the conclusion. If it was greater than 0, it would have been a minimum point. If it was 0, it would mean that the second derivative test was inconclusive and you had to look further into it in order to establish its nature. Part C, we've got a second stationary point, and using algebra, we need to find the x-coordinate of this second stationary point. Now, we're looking for a stationary point, so we're still trying to solve dy dx is 0. So the expression for dy dx was 12x squared minus 9 minus 3 over 2 x to the minus 2, because we know the value of k now. This means that 12x squared minus 9 plus 3 over 2x squared is equal to 0. Now this is a disguised quadratic in x squared, so I could let w be x squared to see things more clearly. 12w minus 9 plus 3 over 2w is equal to 0. I will multiply throughout by w to get 12w squared minus 9w plus 3 over 2 is equal to 0. And now I can multiply everything by 2, leading to 24w squared minus 9w, minus 18w plus 3 is 0. So I can divide now everything by 3 to make the numbers a bit easier. 8w squared minus 6w plus 1 is 0, which factorizes into 4w minus 1, 2w minus 1, which means that either 4w minus 1 is 0 or 2w minus 1 is 0, and therefore w is a quarter or w is a half. Now w was x squared, so if x squared is a quarter, it means that x is the square root of a quarter, which is a half. Remember, I'm not putting the plus minus because we were told that x is greater than 0, so no need to worry about the plus minus situation. And on the other hand, w being a half means that x squared is a half, and therefore x is the square root of a half. The calculator might give you this as root 2 over 2. Now, this solution here corresponds to the point P that was given in the question, so this is point P, and therefore the value we were after is x is root 2 over 2. It is the solution that came out over on the right hand side.